So we're looking at Charles' law, which is the relationship between volume and temperature. Now, an important thing to realize with Charles' law is that temperature is in kelvins, not in Celsius. All of these relationships are relative to absolute zero, which is 0 Kelvin or minus 273 degrees Celsius. Second thing to notice about our example is that this involves an ideal gas. It's a gas that behaves in a theoretical way, not in a real way. Notice that we have our first ideal gas balloon at 200 degrees Kelvin, which is actually minus 73 degrees Celsius. And so that's an unrealistic temperature to have a balloon at for a couple of reasons. A lot of gases actually condense into liquids at that temperature. Nonetheless, we're going to go ahead with this example just so that we can understand the calculation a little bit better. So I have a balloon at 200 Kelvin. It's got a volume of 1 liter. In other words, theoretically, our ideal gas balloon would be about this size. We're going to add some heat and increase the temperature from 200 Kelvin to 300 Kelvin. In other words, we have a 50% increase in the Kelvin temperature. Can you think what the new volume of the balloon will be? Pause the video now. Stop and think. So, a 50% increase in the Kelvin temperature. If you, during that period of time when you paused the video, said that this is 1.5 liters, you are absolutely right. And so the important thing to notice is that the ratio of the volume to the initial temperature is equal to the ratio of the volume to the final temperature, which gives us Charles' law. So volume 1 divided by temperature 1 is equal to volume 2 divided by temperature 2, where temperature is in Kelvin.